In 1916, Albert Einstein predicted the existence of gravitational waves through his groundbreaking theory of general relativity. At the time, Einstein believed these waves would be far too faint to ever detect, even from the most massive cosmic events. Fast forward a century, and advances in both technology and our understanding of the universe have proved him wrong. In 2015, the Laser Interferometer Gravitational-Wave Observatory, or LIGO, made history by directly detecting gravitational waves. But how does LIGO work, and what does this discovery tell us about the universe? LIGO consists of two large laser interferometers located in Hanford, Washington, and Livingston, Louisiana. These observatories, separated by 3,000 kilometers, work together to detect gravitational waves by exploiting the properties of light and space. Their dual locations help confirm signals, reduce local interference, and provide a broad reference for calculating the origins of gravitational waves. The first direct detection of gravitational waves by both LIGO observatories occurred on September 14, 2015. This historic signal, labeled GW150914, confirmed predictions from Einstein's theory of general relativity. It captured the gravitational waves generated by the inward spiral and eventual merger of two black holes, followed by the ring-down of the newly formed black hole remnant. The event marked a groundbreaking moment in astrophysics, providing direct evidence of these cosmic ripples and confirming the violent interactions of black holes billions of light years away. The discovery of gravitational waves is revolutionary because it confirmed a fundamental prediction of Einstein's theory of general relativity. When massive objects like black holes accelerate, they create ripples in space-time, sending gravitational waves across the universe. This detection opened a new window into understanding extreme cosmic events, such as black hole collisions, and provides insights into phenomena that don't emit light, like dark matter. Unlike electromagnetic waves, gravitational waves travel vast distances without being distorted by matter, offering unaltered information about distant cosmic events. This unique ability allows astronomers to study events invisible to traditional light-based astronomy. By listening to gravitational waves, scientists can observe these dramatic occurrences, such as black hole mergers, in ways never possible before. LIGO's future potential lies in detecting gravitational waves from supernova explosions, which mark the end of massive stars and the formation of black holes or neutron stars. Successfully capturing gravitational waves from supernovas would provide a deeper understanding of the violent dynamics involved and offer unprecedented insights into the life cycles of massive stars. LIGO's potential extends beyond detecting gravitational waves. It may also help in the search for dark matter. Researchers at Cardiff University have utilized LIGO data from 2019 to 2020 to look for ultra-low mass dark matter. They developed advanced simulations and new methods to analyze how dark matter could interact with LIGO's laser beams. LIGO's detection of gravitational waves has revolutionized our understanding of the universe, offering unprecedented insights into the most extreme cosmic events. With future advancements on the horizon, what other secrets of the universe do you think LIGO could help us uncover next? Let us know your thoughts in the comments below.